Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all to the next session on the subject of system programming with Linux. Our next few sessions will deal with the socket programming, and today's session will give a recap of the concepts of internet working with Linux. This slide shows the agenda of today's session. Well, dear students, if you're not comfortable with the internet working concepts and this session seems to be a bit fast, you can go through my course of internet working with Linux, which is available on my YouTube channel at this link. Let us start playing. Well, we all know that an internetwork or internet connects different computer networks, allowing hosts on all the networks to communicate with one another. Although various internet working protocols have been devised, but TCPIP has become the dominant protocol suite developed by DARPA. You all must be knowing that TCPIP is a layered architecture with different protocols working on different layers. And a networking protocol is a set of rules defining how information is to be transmitted across a network, specifying how the data to be exchanged is encoded, and how the sending and receiving events are coordinated among the participating processes. Let's see the layers of this TCPIP stack in a bit detail. Well, there are 4 layers of TCPIP stack. The application layer resides in the user space. The transport and the internet layer resides in the kernel space, and the link or physical layer resides in the hardware. Let's talk about these layers one by one. Let's first talk about the application layer. Well, the application layer consists of processes which wish to communicate with unrelated processes executing on other machines on the internet. This layer provides programming interface like Socket API for Linux, WinSock API for Microsoft Windows, and MacTCP for Macintosh. Some famous protocols that work on this layer are telnet, SSH, DHCP, DNS, HTTP, FTP, HTTPS, and so on. And the list is quite long. String-based addresses are used on this layer. Normally we call them URLs, Uniform Resource Locators, and maybe uniform resource names as well. The second layer, the transport layer, this provides host-to-host communication. The 2 famous protocols used on this layer are TCP, which provides reliable full duplex stream-oriented communication, and UDP, which provides an unreliable full duplex packet-oriented communication channel. The addresses used on this layer are 16-bit port numbers. The third is the internet layer. This layer breaks data into fragments and performs routing. And routing is a means of specifying and discovering paths along which the data packets can be sent. Some famous protocols used on this layer are the Internet Protocol, which is a routable protocol responsible for IP addressing, routing, fragmentation, and later reassembly of the packets. ICMP, that is Internet Control Message Protocol, responsible for providing diagnostic functions and error reporting due to unsuccessful delivery of packets. IGMP, Internet Group Management Protocol, responsible for management of IP multicast groups. The addresses used on this internet layer are 32-bit IPv4 or maybe 128-bit IPv6. The fourth layer is the link layer, also called the physical layer, and this is responsible for placing the TCP/IP packets on the network medium and of course receiving the packets off the network medium. Dear students, remember the TCP/IP architecture is independent of the network access methods, frame formats, and the medium. The addresses used on this layer are called 48-bit MAC addresses. And how it actually works, let me quickly tell you how a network message moves through all these layers. Well, the central process running on the application layer push the message down the TCP/IP stack. Each layer attaches its header with the data, and finally this link layer attaches the header as well as a trailer and then transmit it on the network medium. When this transmitted packet somehow reaches the destination computer, the reverse process happens. The packet moves up the stack and each layer detaches its header. Finally, the actual message is received by the target process running on the application layer of the destination computer. Okay, dear students, now you all have a fair idea as to how different layers of the TCP/IP stack work. And let me tell you one of the key challenges. In distributed computing is the unique identification of both the hardware as well as the software resources available on the internet. So let us dig a bit deeper as how different addressing schemes are used on the 4 layers of TCP/IP stack we have just discussed. Let's talk about addressing on the application layer. Well, a host on the internet can be uniquely identified by a fully qualified domain name having 2 parts, the host name and the domain name. The central authority, IANA, Internet Assigned Numbers Authority, manages the assignment of domain names to organizations, which can be 2 or more strings separated by a period. And a mapping of these host names with their corresponding IP addresses is kept in a hierarchical decentralized database, and the service that performs the lookup is called DNS or bind. You can see the RFCs. Make it your habit to have a reading of these RFCs, which are actually documents that specify and discuss the current and developing standards for the internet. Once the domain name is assigned, the organization can add prefix to its domain name to define its host. For example, PUCIT over here is a prefix added to this domain name, and this specifies the host. The organization can also add suffixes to its domain name to define its resources. For example, after this domain name, you can see this path which specifies this resource, that is the timetable. Well, a uniform resource locator is actually a string that we use to identify a resource located on a specific host on a specific domain on the internet. And the general format of a URL is shown over here. The protocols that can appear over here in the URL are not limited to HTTP. It can be HTTPS, telnet, FTP, file, news, and so on. So these are the addresses that are used on the application layer. Let's talk about the addresses on the transport layer. Well, dear students, the transport layer addresses are called port numbers, a 16-bit integer used to identify a specific process to which a network message is to be forwarded when it arrives at a host. Because there may be a machine which is running both the HTTP and SSH service. The HTTP process will be listening on port 80 while SSH process will be listening on port 22. There are 3 major categories of these port numbers. The well-known or reserved ports start from 0 to 1023. Registered ports from 1024 to 49151. And dynamic or ephemeral ports starting from 49152 to 65535. Some famous well-known ports are shown in this table. Okay, the addresses used on the internet layer are more important. I will give it a bit more time. They are called the IP addresses, which uniquely identify the host on the network. Internet Corporation for Assigned Names and Numbers, ICANN, is responsible for IP address space allocation. Well, out of the 5 IP address classes, we normally use the first three, A, B and C. Class D is reserved for multicast, while class E is reserved for research and development. Let's have a quick recap of class A, B and C IP addresses. Well, dear students, every class address is divided into two parts, a network part and a host part. The network part is used to identify the network, and the host part is used to identify the host within that network. Every class has an associated subnet mask, having all bits set to 1 in the network part and all bits set to 0 in the host part. Subnet mask is actually used to get the network address given a host IP address by bitwise ANDing the address with this subnet mask. Let us take the example of class A addresses, and let's take the example of one of the address, that is 1.0.0.0. This is a class A IP address. This address supports about 16 million host addresses ranging from 1.0.0.1 to 1.255.255.254. Note the first and the last address are not assigned to a host, as the first address is used to identify the network itself, while the last address is the broadcast address, which is used to send data to all the hosts on this network. In the same fashion, you can interpret the data and examples of class B as well as the class C addresses. Well, dear students, there are about 4 billion IPv4 addresses. Seems to be large, but this address space has gone full. ICANN is using a scheme called classless internet domain routing, CIDR, which has significantly extended the useful life of IPv4. ICANN has taken away many class A and class B addresses from organizations and is using them to create IP addresses with lesser number of host computers, and then issuing these classless IP addresses to organizations. Consider /28 networks. I can control the leftmost 28 bits for the network part, with remaining 4 bits under the control of the organization it is issued to. This gives the organization about 14 IP addresses to use as host. The problem that arises is, what if the organization is having more than 14 hosts? And the solution proposed is private IP addresses. Well, dear students, IETF, Internet Engineering Task Force, has designed 3 address ranges as private. These are non-routable and can only be used either in a fully disconnected network or on a network behind a firewall. Firewalls actually translates private IP addresses to public IP addresses using a process called netting. This network address translation allows a single device called the gateway computer having a public IP address to act as an agent between the internet and the private network. So this means that a single public IP address can represent an entire group of computers. So we can always say that CIDR and netting has significantly extended the useful life of IPv4. These are the IP address ranges for class A, B and C. This is a typo. This is 192. This is not 172. Dear students, the days of 32-bit IPv4 are going to be over soon. So we need to switch to 128-bit IPv6 addresses, using which we can assign over 340 trillion addresses. That means 1 million IPv4 addresses to every star in this universe. We will be using IPv4 in our socket programming sessions. So let's move ahead. So these are the addresses used on the physical layer, that is the 48-bit MAC address. It consists of 2 parts. The most significant 3 bytes are assigned by IEEE to the manufacturer that uniquely identifies that particular manufacturer, and the least significant 3 bytes are assigned by the manufacturer that makes the address of that device unique. Okay, dear friends, now we are theoretically equipped to jump onto the Linux terminal to see the proof of different concepts that we have discussed. But before I do that, let me show you the machines on which we will be working on for the rest of the session. Well, right now I am working at my home. My laptop is running a Mac operating system on which I have installed Sun VirtualBox to build my virtual machines. This IP 192.168.100.6, this has been assigned to my Mac via the home router. The 3 virtual machines right now are running the Kali Linux, the Microsoft Windows 10 and Ubuntu Server. Ubuntu Server is having the IP address of 192.168.100.20. Kali is having the address of 192.168.100.21, while Microsoft Windows 10 is having the address of something.22. Okay, let's move on to these 3 machines and understand their network settings before running and using different services on them. This is our Kali machine. I'm right now root because I have to run certain privileged commands. So instead of using sudo again, I have logged in as root. Let me use ifconfig command, which is used to configure the network interfaces. And when called without argument, it displays the status of currently active interfaces. This is the name of the interface, usually a driver name followed by a unit number. And you can see the IP address of this Kali machine is 192.168.100.21. This is the subnet mask, this is the broadcast address, and this is the hardware address. And of course, this is the loopback. Fine. To check the default gateway address, we can use the route command. Let me clear screen. This route command is used to show or manipulate the IP routing table. Let me shrink it a bit. Well, fine. This 192.168.100.1 is the IP address of the gateway interface of my home router. Well, dear students, these TCPIP configuration parameters like the IP address, the broadcast address, the subnet mask, and the IP of the gateway can be assigned either statically or via DHCP. In our case, these are assigned via DHCP service, which is running on my home router. And if you want to dig out deeper, please watch my video session on the subject of internet working with Linux, in which I have shown the configuration of these in detail. Okay, let me clear screen of our Kali and let us move on to the second machine running Ubuntu Server. And again, I am root on the Ubuntu Server. And these are the network configuration parameters. The IP address is 192.168.100.20. And this is the default gateway address, which is the same. Let us move on to the third machine as well, running Microsoft Windows. And let me move on to the terminal, a command prompt. Okay, and let me run the ipconfig command over here. This /all flag shows you more details. You can see over here. Well, the host name is Windows 10. The IPv4 is this 192.168.100.22. This is a subnet mask. Okay, fine. This is the DHCP server. and this is the DNS server, and so on. So all these parameters have been assigned via the DHCP service running on my home router. Now that we have seen the TCPIP configuration of all the three machines, let us check the connectivity. Let me clear screen. While sitting on the Windows machine, let me ping Kali first with the IP of 192.168.100.21. So we are successfully pinging. Well, ping is the packet internet gropper, which is a network diagnostic tool that sends ICMP echo request to network host to check connectivity. Let us check for the Ubuntu server as well, having the IP address of .20. Okay, so that is great. Let me move on to the Kali terminal over here, and let me ping 192.168.100.20, which is the IP of the Ubuntu server, and let me ping Windows 10 as well, that is 22. Great. And let me ping myself, that is Kali. That is great. So we can ping these machines with the IP addresses. Can we ping these machines by names? And the one simple way of doing that is to put the IP and the name mapping in the etc host file on all these machines. Let us check it on the Kali cat etc host. Well, I have given the IP and the name mapping in the etc host file for all these 3 or 4 machines, and of course I can ping Ubuntu server, and of course I can ping Kali with name, and I can ping Windows 10. Okay, so that is great. Let me clear screen. Let's move on to the Ubuntu server now, and see the internet services list, and that resides in the file inside the etc directory. Let me use less etc services. Well, this file provides a mapping between different internet services and their underlying assigned port numbers and protocol types. For example, you can see echo is running on 7, discard is running on 9, daytime on 13, character generator is on 19, and so on. We have telnet on 23 and SSH on 22. Okay, so of course telnet provides a bidirectional interactive text-oriented communication facility normally used for remote login, but it transmits all data in clear, so it is not secure. So these days telnet is replaced by a secure shell protocol in which the user authentication as well as the data transfer are all encrypted. And let us check the status of SSH service right now on Ubuntu. Well, it is running. Let me stop it. Let me check the status again. Fine. And let me restart it. Systemctl start SSH. So the service is running. That is great. Let us check the status of the sockets using, let's suppose, netstat -ant for TCP only, and let me grab 22 because SSH runs on 22. So this shows that this SSH service is running and it is waiting on the local computer, that is Ubuntu server, at port 22, and is ready to accept a request from any machine. Let us move on to Windows 10 and do a remote login to Ubuntu server. Let me use PUCIT. And let me give the IP of Ubuntu server, that is 192.168.100.20. Port is 22 and I want to use SSH. Let me click open. I want to log in as, let's suppose, Arif, and the password of Arif is, I'm not going to tell you that. And well, right now I have successfully logged in on Ubuntu server. You can see host name is Ubuntu server. Who am I? And I am Arif. So that is great. Let us move on to the Kali machine now and do a remote login to Ubuntu server. Okay, let me come over here. Well, remember, this is again a terminal of the Kali machine that is black. Let me confirm that. Fine. Let me do SSH root at 192.168.100.20. I have enabled the login of root for this session, although it is not recommended. Okay, so that is great. Right now I am root and I am on Ubuntu server. Well, let me check the status of the sockets using Netcat-ant, and let me grab 22. Let me shrink it a bit. Well, dear students, you can see over here now we have two established connection. See this connection. At this IP address, which is the IP address of Ubuntu server, on this port there is a connection that is established with this machine, and this is the IP of Kali machine. While over here in this line, the connection that is established is from the Windows 10 machine, and we still have a process listing at port 22 to accommodate for any other session. Okay, so let me move on to the Kali over here and let me run netstat-ant grep 22. You can see we have one established connection with the server. So netstat is a great utility. You can use SS as well to investigate the sockets. Okay, so far so good. We are done with SSH. Let's talk about some more services. Let me clear screen. Remember, students, I'm on Ubuntu server right now. Let us check about a server that is known as inetd. Okay, extended internet daemon. This is also called super daemon. Dear students, instead of starting a service at system startup and be dormant until a connection request arrives, we normally use inetd, which is the only daemon process started. When a request for our service comes in, the inetd starts the appropriate service. Do read this man page. If this is not installed on your machine, you can install it using sudo apt-get install. Let us check out what all services are managed by inetd on our Ubuntu server machine. For the directory which contains the configuration file for inetd is @c-inetd.d. Let me do ls. While this directory is @c-inetd.d contains configuration files of all services which are being controlled by inetd server, and these are chargen, daytime, discard, echo, telnet, time, or vsftpd, and there can be others. Well, all these configuration files for these services are read by inetd. Let me read them for you. Let me read chargen. Character generator protocol. Upon connection, the server starts sending arbitrary characters to the host until the connection terminates. So you can see we have the service for the TCP as well as the UDP. The important line is disable is equal to no. Once you will check out, you will find disable is equal to yes. That is by default this character generator service is disabled. Put a no over here. Save and quit. Let me show you daytime as well. I have also enabled daytime by putting a disable is equal to no for both TCP and UDP. Similarly, you can see the rest of the file as well. Let us see the ports on which these services run, and we can see them from the @c services file, and we can grab, for example, daytime. So daytime runs on port 13. We can grab chargen, that is character generator, which runs on port 19, and we can check out the discard as well, which is similar to the local file div null. We can check for, let's suppose, echo as well. Okay, echo runs on port 7, so that is great. Remember, dear students, right now I am on my Ubuntu server. Let us see the status of the inetd on this server. Let me first go to my home directory, let's suppose, and use systemctl status inetd. So inetd is inactive, it is not running. So let me run it. Let me say start this service, and let me check the status again. So now it is active and running, and there are about 11 services which are being managed under inetd right now. Okay. Let us see the status of the socket for, let's suppose, daytime service. netstat-ant grep, and the daytime service runs on port 13, I think. Well, yes, it is listening. Remember, dear students, daytime service is listening at this port 13 on Ubuntu server and is ready to accept an incoming connection from any port, from any remote host. Let us check the character generator service as well, which I think runs on 19. Well, this is the line corresponding to character generator, and these second lines actually show the established TCP connection from Kali machine to Ubuntu server at port 22 for SSH, as well as from Windows machine. Let us now move on to the Kali machine over here. Right now I am on Kali machine. Okay, so let me use Netcat. Netcat is a TCPIP Swiss Army knife. Let me show you the man page first. So this is a TCPIP Swiss Army knife. In simplest word, it is used to read and write data across network connections. And do see the man page for details. And the simple usage is you use the ANSI command, provides the host name or IP and then the port. Okay, so let me use ANSI 192.168.100.20, which is the IP of the Ubuntu server, and let me use 13, and this is for the daytime service. And you see, on connection the server returns ASCII character string of current date and time. Let me use 19, and let me use the name instead of IP, Ubuntu server. And you see, character generator on connection, the server starts sending arbitrary characters to client until the connection terminates. Let's terminate this connection. So I've used this to access the chargen protocol, and let me use the discard protocol at 9. At port 9 the discard protocol runs, and in discard protocol the data sent to the server is discarded, nothing is returned. This is going to be discarded, just like the file div null, so nothing falls back. Let me quit. Let me use echo as well, and echo runs at port I think 7. And whatever data is going to be written over here will be sent to the Ubuntu server and it will be returned as such. So let me write the famous saying, learning, okay, correct spelling, learning is fun with Arif. This is great. Okay, bye. Control C. That is great. That is great. I think that is enough. Let us fall back to the slides. Right, dear students, now I think you have a fair idea of the working of different client-server protocols. Inshallah, in our next session, we will learn writing our own client-server programs, the client programs as well as the server programs using C. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Happy learning and Allah Hafiz.